Hi everyone. So let's solve a couple of more problems. We're almost done with the problems of this chapter. So 31. It says if P is a positive prime, prove that the square root of P is irrational. So first, assume it is rational. So that means we can write m over n as the square root of P for some integers m and n, or n is non-zero. So that means we can write m squared as n squared multiplied by P. By the prime factorization theorem, we can write m as P1 alpha 1 pk alpha k, and similarly n is P1 beta 1 up to pk beta k. So just to clarify things, you don't have to have the same prime, but you could list m and n as multiple of primes of the same length, where if one of the primes don't exist in, like if it exists in n but doesn't exist in m, just raise it to the power 0. Just allows us to handle the proof and the proof mechanics in an easier way. So we have the identity. M squared is equal to n squared times P. So from this, we have that P1 to alpha 1 pk to alpha k is equal to P1 to beta 1 up to pk to beta k times P. So this means that P has to appear in the prime factorization of M. So therefore, P divides M squared, and as it is prime, it cannot appear as it is prime, it cannot appear out of nowhere. So that means that P divides M hence we can write M as products of those primes, where p is one of those guys. So, but p must appear to an even power, as follows. So there exists an I such that pi alpha I is equal to p alpha I. So that means that this means that we have P1 to alpha 1, Pi, let's call it P to alpha I, and Pk to alpha k. This is equal to P1 to B1, Pk to beta k times p. Canceling a p in the two parts of this equation, we get that p divides n squared, which means that p divides n. So therefore there exists a j such that p to beta j is equal to one of those beta j's is equal to p j to beta j. So therefore we have P1 to alpha 1, P to alpha I, Pk to alpha k. This is equal to P1 to beta 1, P to beta j plus 1, Pk to beta k. So we must have that to alpha I is to beta j plus 1, but that's impossible as the left hand side is even and the right hand side is odd, which gives us a contradiction, and we can trace this contradiction to assuming that the square root of p is rational. So the main core of the idea lies in the fact that we cannot just have a p appear out of nowhere in the factorization, and so things cancel out and we get even is equal to odd. So that's the main core of the idea. So what I like to do is that I like to probe and understand things all the way to the main core of the elements, And then once you understand the main core of the elements, you really can fixate to the whole theoretical framework. So yeah, I hope you guys enjoyed the video, and I'll see you in the next one. Bye.